What if I told you that almost everything you see in the universe is a lie? That the stars, the planets, and even you make up less than 5% of reality? The rest is invisible, untouchable. Yet it holds the universe together. Scientists call it dark matter. But after decades of searching, they still have no idea what it really is. And what they might be missing could change everything we know about the cosmos. The universe is full of secrets, but none more haunting, more elusive, and more puzzling than the mystery of dark matter. For decades, scientists have stared into the night sky, watching galaxies spin, stars cluster, and light bend in ways that make no sense if we only count the matter we can see. Ordinary matter, planets, stars, gas, dust, and everything we know, makes up less than 5% of the cosmos. The rest, the unseen bulk of reality, is hidden, invisible. Yet it exerts a gravitational pull so strong that without it, galaxies would fly apart like sparks from a fire. This invisible force is what scientists call dark matter. But what is it really? Why can't we detect it? And what if our entire understanding of the universe is missing the truth? The hunt for dark matter began almost a century ago, when astronomers like Fritz Zwicky noticed that galaxies inside clusters were moving far too fast to be held together by the visible stars alone. He concluded that there must be some unseen, missing mass holding everything together. Decades later, Vera Rubin's groundbreaking work with spiral galaxies showed the same pattern. The outer stars were moving at incredible speeds that should have torn galaxies apart if gravity came only from visible matter. Something was there, holding the galaxies together, something massive, something invisible. And yet it wasn't light. It wasn't energy as we know it. And it wasn't any particle we could find. Since then, dark matter has haunted astrophysics. A ghostly presence making up roughly 27% of the universe, compared to a meager 5% of ordinary matter. The rest, about 68%, is even stranger. Dark energy, the mysterious force pushing the cosmos to expand faster and faster. But while dark energy is a vast puzzle of its own, dark matter is more concrete, more gravitational, more tied to the shape and structure of the universe itself. We know it must be there. Without it, galaxies, clusters, and even the cosmic web of large-scale structure would fall apart. But the question remains, what is dark matter made of? For decades, scientists thought they had a leading candidate, WIMPs, or weakly interacting massive particles. Heavy, stable particles that barely interact with ordinary matter except through gravity. If they existed, they would fit perfectly into our theories, explaining the missing mass. Underground detectors, shielded from cosmic rays and noise, were built around the world to capture even the faintest hint of a WIMP passing through Earth. Yet time after time, the detectors stayed silent. Not a single confirmed detection. Each failure forced scientists to rethink, to dig deeper, to ask if perhaps they were searching in the wrong place or with the wrong assumptions. Other candidates emerged, axions, hypothetical ultra-light particles that could ripple through the universe like invisible waves, sterile neutrinos, ghostly versions of the neutrinos we already know, interacting even less with matter than their already elusive cousins. Or even primordial black holes, tiny collapsed objects born in the earliest moments after the Big Bang, drifting invisibly through space. The list of possibilities grew, but with each experiment, each test, the silence continued. The universe refuses to give up its secret. This raises a deeper question. What if dark matter doesn't exist at all, at least not in the form we imagine? What if instead of unseen particles, the real problem lies in our understanding of gravity itself? Some scientists propose that Einstein's general relativity, though remarkably successful, may not fully describe gravity on cosmic scales. Modified Newtonian dynamics, or MOND, suggests that at very low accelerations, gravity works differently than we think, eliminating the need for dark matter altogether. Others argue for even more exotic alternatives: extra dimensions, new forces, hidden interactions. But so far, none have explained all the evidence as neatly as dark matter. The search has become one of the greatest hunts in modern science. Vast underground detectors in abandoned mines using ultra-pure crystals, supercooled liquid xenon, and massive shielding. Telescopes peering deep into space, mapping the distribution of galaxies and gravitational lensing patterns. Particle accelerators like the Large Hadron Collider smashing matter together at near-light speeds, hoping to create or glimpse a trace of dark matter. Each approach probes a different piece of the puzzle, but the silence grows louder with every null result. And yet, there are hints, subtle signals that keep the chase alive. Tiny anomalies in cosmic background radiation maps, unexplained X-ray emissions from distant galaxies, patterns in how galaxies form and evolve. These could be whispers of dark matter, shadows cast by its presence, but they remain unconfirmed, fragile clues in a sea of uncertainty. The truth is that dark matter, for all our effort, is still a ghost in physics. It shapes galaxies, bends light, sculpts the universe. Yet we cannot see it, cannot touch it, cannot pin it down. For all we know, we may be chasing shadows, chasing a concept that exists only because our theories are incomplete. Perhaps dark matter is not one thing, but many. Perhaps it is not particles at all, but a property of space itself, hidden in the quantum fabric of reality. Or perhaps it is right in front of us, invisible but waiting for the right question, the right experiment to finally reveal itself. And this is what makes the hunt so powerful. The search for dark matter is not just about solving a cosmic riddle. It is about pushing the limits of human knowledge, testing the very foundations of physics, and daring to ask if the universe is far stranger than we ever imagined. If we find dark matter, it will open an entirely new chapter in science, a window into forces and particles beyond the standard model, a deeper understanding of the cosmos. If we fail, if it does not exist, then the very laws of physics may need to be rewritten, reshaping our place in the universe. Right now, around the world, scientists continue the chase. In deep mines, detectors wait in silence, hoping for a faint flash of light that signals a dark particle striking an atom. In space, satellites map the gravitational fingerprints of invisible mass. In laboratories, theorists run endless equations, trying to imagine what form this unseen matter could take. Billions of dollars, decades of work, thousands of scientists, all chasing something no one has ever seen. And yet, this is what makes science beautiful. Not the answers we already know, but the questions we cannot stop asking. What is the universe made of? Why is there so much that we cannot see? What else lies hidden in the darkness, shaping everything while staying invisible to us? These questions drive us forward, into the unknown, into the frontier where mystery meets discovery. Perhaps one day soon, an experiment will capture the first true signal of dark matter, and we will look back at this age as the dawn of a new revolution in physics. Or perhaps we will learn that the truth is even stranger, that reality itself bends in ways our minds have yet to imagine. Either way, the hunt continues. And until we find the answer, the universe will keep its deepest secret locked in the darkness. Because the story of dark matter is not just the story of invisible mass. It is the story of how little we truly know and how much there is still to discover. It is a reminder that even after centuries of science, after Einstein and quantum mechanics and space telescopes peering to the edge of time, the universe still holds mysteries so vast they can humble us. And that maybe, just maybe, the most important discoveries are the ones we haven't even learned how to see yet. So as we look up at the night sky, at the galaxies whirling and the stars burning, remember this: most of what you see is not what is really there. The true universe is invisible, hiding in the dark. And until we solve this mystery, we are explorers fumbling in the shadows, reaching for a truth beyond imagination. The hunt for dark matter continues, and what scientists are missing may be the key not only to understanding the universe, but to understanding reality itself.